can graph, you can't graph circles on it. You can graph parts of circles, but you can't graph circles. Okay, so when we go to graph, lines, boom, boom, it's either, one intersection point, or you have parallel, no intersection points, or it's the same line and you have how many intersection points? Infinite, right? Okay, so when you're graphing other things, like what did we do in 9.1? We talked about graphing 9.1. I know it was a long time ago, but what shape? Yeah, circles, awesome. So you have a circle. Now, if you have a circle and a line, it can intersect in how many spots? None. How many? 2, or, well, that's not very good, but how many? 1. Yeah, easy. Or you have a circle. That's not quite a circle. You have an egg. You ever think about chickens? I was just thinking about this over the weekend. How phenomenal is it? Do you know how often chickens lay eggs?
Every day.
Daily. You think about that. That chicken is laying a solid egg every day with the perfect shell every day. Think about that. Did you know that the chicken has stages of that egg growing in its body every single day? Right? Because it can't actually develop the whole egg in one day. You know this? It is. It's crazy. You think every day that a hard egg is coming out with the perfect shell. And you know what's amazing about the perfect shell? Did you know the chick can actually breathe through the shell? It's breathable. But liquid can't come out, but it has a breathing membrane. And the baby chick on the inside develops a little point on the beak that it can, crack the egg open every time. Unless you eat it. The death of the egg, right? But just think through that for a second. Evolutionary process. How did they get it? If they didn't get it right the first time, the poor chick suffocated to death. Or if the chick didn't develop the perfect little beak to break it open, death. Or maybe the first egg came out and was a little too soft and the chick just fell apart. And it's like, well, that didn't work. We better try again. Do you think they could perfect it on the second or third try? No. What does evolution tell you? It needs how many years?
Billions.
Yeah, billions, millions. It's like, well, yeah, then what would happen to the chicken unless it perfected on the first try or the first few tries? What happens to the chickens? Death, right? It's incredible. Think about it. Next time you go, don't take for granted the egg. I was just thinking about this weekend. I was like, wow. And did a little research on it. Incredible. So here you have the egg. So now you could also have a parabola. How many places could a parabola connect? 1, 2, right? Or you could even have a which we haven't talked about. But it doesn't matter, it's the equation is the same. You could have this, you'd have 1, 2, 3, and 4. So graphing would be really easy, just punch it into Desmos, hit enter, and it gives you all the intersection points. You can't do that, right? Calculator would be a little cumbersome, because you can't graph the full thing. So then you have 2 options. You're not graphing, so what are your 2 options? You told me you can either do substitution or addition, subtraction, right? And so actually either one would be acceptable to use. You could do substitution or addition, subtraction on these. And so usually substitution ends up being the easiest. So if you have x squared minus, or x, I'm sorry, like x equals, we'll just do an example for you. Y squared minus 9, right? And then you have the other one is x minus 4y minus 12 is equal to 0. Easy substitution. What does x equal? Y squared minus 9. So what would you plug in for x? Y squared minus 9, right? So no different than any of the other ones you've done in the sense of just substitution. Same concept and rules would apply. Now, what kind of equation am I looking at? Is it very solvable? Absolutely. Why can you easily solve this one? Because you've done it. Okay? What kind of equation is it? It starts with a Q. Quadratic. Yeah, how many different ways do you have to solve quadratics? Graphing, if you want, which you guys don't graph with the, So we're not going to do the graphing method. You could, if you had a calculator, just graph that, look for the x-intercept. So you're not going to graph it, so what would you do? You're not going to complete the square because nobody remembers how to do that, although it's really, once you get it, it's really quick. But you probably won't do it. I've never seen people, almost never see people use the completing the square method. So then, what are your other two options? Factoring, which not always factorable, but factoring, and then your fourth option, which everybody hopefully knows and goes to, which is fine, nothing wrong with going to it, is the quadratic formula. So solve it. Now, once you find y, what do you got to do? You got to plug back in and solve for x. So remember, what kind of, right? And it would be helpful if you knew that this equation forms what kind of graph. It's helpful to think through. What kind of, does that form? That forms a line, right? Because it's an x and a y with nothing being squared. So that forms a line. So you know you've got a line. Now this one, we haven't worked with the y squared, but it's the same thing as an x squared, except it's just a sideways, like that. So, but you have one of those and one of these, so you have three options. None, one, or two. There you go. So you can solve for that, right? I mean, you just have to do the quadratic formula or something, which hopefully you have some skill sets to do. I think you do. Now, how do you know you would get like a no solution when you're solving? How do you know you have a no solution one? Because you're not looking where the slopes are parallel, right? Oh, you're not looking where slopes are parallel because you're looking at this and you're looking at this. How would you know you're going to get a no intersection point, no solution? A remainder of 0?
No, like, if it would be like, if you plug back in like a fraction or something, and then, like, your denominator comes out as a 0, wouldn't that be like a no solution?
Not for this. How do you get a no solution out of this when you're solving this?
Oh, a number equal to a number. Or like a 7 equals 7.
Yeah, you could end up with something like 7 equals 7. That's true, and that would be all reals, right? Or you could end up with like a 0 equals 7, and that would be a no solution. But you're not going to get that here. I'll give you a pro tip here. Here you're not getting that. You're solving a quadratic. You're going to get something out. Okay? But in that something, what would define that your lines don't intersect? Nate's made a few valiant attempts to jump, and he did remember all reals, no solution. That's when we were dealing with lines. You're solving this, how do you know you're going to, it's like, oh, I don't get a solution out. What kind of solutions would you get that would mean you actually have no solution?
Negatives.
Yeah, you're on the right track. Negatives, what kind of negatives? You're on the right track, maybe, or you're way off, but the negative plays into it. Not negative answers, but negative where?
Roots.
Yeah, negative roots, which would give you what kind of answers? Imaginary. So if you have imaginary intersection points, do they intersect? No. You could state, oh, it's an imaginary intersection point, but for this, we're looking for where do they intersect. And so if it looks like this and like this, you have like this one and this one, you have imaginary intersection points. Therefore, any solution? No solution. Good work, we got there, guys. Right, way to go. Okay, so, you'll have a no solution one. Or you have like a, let's go with, let's do a double one, x squared. Now, with these, it doesn't matter, like, if you know what that shape is right there. You might say, oh, that's a circle. Because it has an x squared and a y squared. Hopefully your brain would tell you something like that because you've worked hard in math. And on 9-1, what did we deal with? X squareds and y squareds. Now, it doesn't always mean that's actually, because there's other graphs that we haven't dealt with, that doesn't always mean you're going to get a circle. It could be an oval or something like that. But it doesn't matter because just think it's some sort of, in the end, you don't even have to know what the graphs are. Just visually it could help you to think through. Circle, oval, same concept when you're considering different types of intersections. So this circle, sure, call it a circle. Do you need to graph it? No, don't need to graph it at all. Then your next equation on this is going to be like 3x squared minus y squared equals 8. 3x squared minus y squared is equal to 8. Okay, again, you look at that one. what does that look like? Well, it's got an x squared and a y squared, so it's a circle. Okay, sure. Probably actually not a circle. Doesn't matter because the general idea would tell you, sure, you have two circles, even if they're not circles. Meaning, it's like two ovals. So when you look at that, you say, okay, I have two circles, and again, you don't have to know this, but you have a circle, and then you have another circle. How many intersection points could you actually have? Or it could matter in the sense of like, well, what if I have a circle and I have an oval, right? You could have 1, 2, 3, 4. You could have a circle and a circle. You have none, right? So, you know, again, all the options, there's a lot of options of what you could have. It doesn't matter because how are you going to solve it?
Multiply the lower one all by 2.
Yeah, so in this case, why does elimination line up really nice for us? Nature said, oh, multiply the bottom by 2, right?
Yeah.
Because x squareds are going to add together nicely, right? And then y squareds add together nicely. Over here, substitution was straightforward. You already had x equals here. You don't have anything, right? You just have, you could do substitution by solving for x squared. That would work too. But I would go, yeah, Nate recognized elimination would be super easy because you just multiply this bottom by 2, right? And so you get 6x squared minus 2y squared is equal to 16, right? And then you get x squared plus 2y squared is equal to 12, and then you just combine those. So you get 7x squared, those cancel out, is equal to 28, and then x is equal to plus or minus 2. And so that's actually really nice. But now, excuse me, don't forget, once you have what x is, right, what do you got to do? Plug in and solve for 1. So now you're like, okay, I know my coordinate points, I'm going to have 2 comma something, then I'm going to have negative 2 comma something, right? So when you plug in, right, you plug in and you're like, okay, if I plug in, let's say the easy one to plug into would be right up here. If you plug in a 2 up there, because that's what x is 2 or negative 2, you plug in a 2 up there, you're going to get 2 squared plus 2y squared is equal to 12. So you get, right, 2y squared is equal to 8, and then y squared is equal to 4, and then y is equal to plus or minus 2. So now you see when you plug in a 2, what are the answers you get out for y? You get a plus or minus y. Well, a plus or minus, right? A plus or minus 2 there. So, yeah, you get, when you plug in 2, you either get out 2 or negative 2. That's not really a good way to write the coordinates. The way to write it would be when I plug in 2, I get out 2. When I plug in 2, I also get out a negative 2. Which would make sense because maybe it's something like this, And so you have these two answers when you plug in 2. And then what happens when you actually plug in negative 2? Well, this is really easy for you because a negative 2 squared is the same thing as 4. And we're right back to over here. And so you actually get out the same thing, plus or minus 2 there. So it's just solving systems of equations. Not linear, but systems of equations. So you have to be comfortable with solving quadratics, comfortable with working with square terms. But there's no math that you haven't done before. Maybe haven't seen before in terms of the substitution or solving the squares values. That's true, but there's no math that you haven't been able to do before with just substitution and solving. Okay. Again, are there some that are no solution? You bet. And what signifies no solution? We finally figured it out. What was it? When you end up with an imaginary, right? And then you're like, oh, that means they don't intersect. If you've done it correctly, of course. Like, you end up with imaginary and it has to be done correctly. Okay? So, that should clarify, hopefully, everything for that. And then the story problems, it's just the same way on the story problems. The same way meaning you just set up equations, systems of equations. You're not setting up systems of linear equations and solving. You're setting up systems of equations that might look like this, or might have this, might be a linear, and then you just solve them the same way. Okay? So that's going to give you hopefully the tips and tools you need to finish this. All right? Okay, so let's do this. Let's just utilize our time. This will be due tomorrow for 9/8. Have that done by tomorrow. We'll just pause there. We won't go on to 10.1. We'll pause there on the homework for tomorrow. We'll ease up on that and make sure 9.8 is done by tomorrow. Sound good? All right, so utilize your time here. Get that done, or work on it, or just start it. That's good. Start it.